Hi everybody, this is the Math 30-1 Trig 2 review. This is question 2a. We're going to prove the following trigonometric identities. Okay, as I go through this, I'm going to try to help you guys out by modeling a procedure that I think is going to make this a little bit more efficient for you, okay? I know that there's often a temptation when you're proving these things to say, I'm just going to jump right to writing things in terms of sine and cosine. And yeah, sometimes that works, but oftentimes you're making it a little bit harder on yourself than it needs to be. So let me just help you out with this here. Now, first of all, to prove this here, we're going to separate the left and the right-hand sides from each other because we want to show independent of each other that these two sides are equivalent to the same expression. And I'm going to focus on the harder side, the more complicated side, because it's easier to make something simpler than it is to try to make this side more complicated. Now, the very first thing I'm going to look for, number one, is I'm going to look for Pythagorean identities. I'm looking for the squares. I want to deal with squares first. Now, I don't see anything that's being squared, so that's no good. So the next thing I'm going to look for here is any obvious algebra that I can do. And in this case here, what that refers to is what I'm seeing here. I'm going to expand this out. Okay, I've got two binomials multiplied together. I'm just going to expand that out here. So 1 times 1, 1. 1 times secant is just going to be secant. Negative cosine times 1, negative cosine. Negative cosine times secant is going to be negative cosine x secant x. Okay, good. Now, next thing I do here is I'm going to go look for, I'm going to go right back to the beginning. Do I see any Pythagorean identities? Did I create any? And the answer is no, I didn't. Then I'm going to look at this and say, did I create any obvious algebra for myself? Well, no. No, there's really not much I can do here. So the obvious algebra step is no good. Now what I'm going to start to look for here is I'm going to start to look for the reciprocal identities. So like tangent, maybe flip it to cotangent or cotangent to tangent. Or I'm going to look for stuff like that secant there, and I'm going to write that in terms of, I could think of it in terms of writing it in cosine as cosine here, but you should notice that cosine times secant, because secant is 1 over cosine, these two are actually going to cancel each other out. Okay, secant is 1 over cos, cos times 1 over cos. Those are actually going to go away, and this is going to become 1 plus secant x minus the cosine of x minus 1. So what I'm taking into account here is that this is a reciprocal. Okay, it's a reciprocal of cosine. When you multiply reciprocals, you get the 1. Now, minus 1 because I was subtracting it. Except those two are going to cancel now. So now I'm just left with the secant of x minus the cosine of x. Okay, now I go right back to the beginning. Do I see any Pythagorean identities? Nope. Do I see any obvious algebra here? Nope. Do I see anything where I can take advantage of the reciprocal identities? Yeah, well, nope. Nope, it's not like that secant is multiplied by that cosine. So now at this point here, now maybe I need to write this as 1 over cosine. Now maybe I should do that. Now, did I create any Pythagorean identities? Nope. But now I do have an obvious bit of algebra to do here. I need to add those two fractions together. So I'm going to multiply this by cosine, multiply this by cosine to get a common denominator. And so now this is going to be cosine x in the denominator. In the numerator, I'm going to get 1 minus the cosine squared of x. Now, I go right back to the beginning. Do I now have any Pythagorean identities? Yes. Yes, I do. 1 minus cosine squared is equal to sine squared. So this is going to become sine squared of x over the cosine of x. And now I go back, do I see any Pythagorean identities? Well, okay, please don't be the person who goes, yes, sine squared is 1 minus cos squared. Oh, and 1 minus cos squared is sine squared. And so sine squared is 1, no. That will go on forever. So don't do that. We got to always be moving towards our goal. And in this case here, sine squared is like having two sine factors there. And I can produce this kind of this ratio identity. One of those sines over cosine is going to be tangent. And there we go. we've now got the left-hand side equal to the right-hand side. That took a little while here, but that's okay. It's good. It's character building. It's good to have nice long questions like that that require a bit of work. Okay? Remember that at each step along the way, we are equivalent. We're completely equivalent to the one before it because we're using an identity to simplify it.